So now what we're going to do is look at the graph of the cosecant function. And right away, what we have to remember is that cosecant is 1 over the sine. So that means, again, focusing on the denominator, cosecant is undefined when sine of x is equal to 0. And remember, sine of x is equal to 0 at all the integer pi's. So I'm going to say 0, pi, and 2 pi. Now, in order to graph this function, again, I'm going to put the x-axis, or the y-axis here. What we want to do is look at the graph of sine of x first, because we want to be able to base it off of sine of x. I'm going to show you a little trick that we can use to graph reciprocal functions. So there's 2 periods of sine. I'll just go over here because we're here. Why not? There. Okay. So there's the graph of sine. So in a different color, what I have to realize, or what I'm going to do here is, to graph a reciprocal function, think about the y values. When the y value is 1, the reciprocal is also 1. So that means the functions are going to agree at 1 and also -1. When y is -1, the reciprocal is -1. So I know the graphs are going to do that, or pass those points. So the other thing to look at is, though, since the cosecant is undefined whenever sine is 0, well, when is sine 0? All the integer pi's. I'm going to put asymptotes at all the integer pi's, because that is going to be what happens. So technically there's an asymptote right over top of the y-axis there. That's okay. Now, how does the rest of the graph get formed? Well, notice, and I'm going to start right here at this first maximum point here. Notice as I move away from the maximum point, the y values of sine get smaller. Well, so the reciprocal of something smaller than 1 is bigger than 1, right? Pick a half, for example. What is the reciprocal of a half? 2. So that means the graph is going to pass through those angles, comma, 2. In fact, as we get closer and closer to 0, the reciprocal gets larger and larger and larger. So now all of a sudden we have in red, so ignore the blue graph pretty much, in red that's the graph of cosecant. Same happens in the negative direction, and the positive direction, and the negative direction, and so on and so on. So this is what the graph of cosecant looks like. It's a bugger, isn't it? So the period is still 2 pi because it follows the graph of sine of x. The domain is basically anything except for the integer pi's. Remember, 0 is an integer, so that is included there as well. The range, that's a little funky. So the range, you notice, anything that was on the graph of sine does not happen on the graph of cosecant. But notice, the 1's do. So the range is broken up into -∞ to -1, also 1 to infinity. Okay, remember we put a union there to show that they're both part of the range. As far as the asymptotes go, x is equal to k pi. Okay, so remember, domain and asymptotes kind of complement each other, right? And x-intercepts, well, there are no x-intercepts. The graph never crosses the x-axis. So this is a weird one, okay? Well, equally as weird and mystifying is our secant function. And remember, secant is 1 over cosine. So following along the same rules here, it's undefined when cosine is 0, which means that I'm only going to put the ones in the first period. We know that there's many more, but I know that the odd pi's over 2 are where cosine is 0. So I am going to graph the cosine function just like so. Okay, so I'm going to build the secant function off of the cosine function. So let's see what happens here. So I know, again, since secant is the reciprocal of cosine, I know that when I originally got a value of 1, the reciprocal is going to return the same value. Same with -1. I also know that when cosine was equal to 0 is where secant is going to go undefined. So that's all the pi over 2's. And I also know that if I take the reciprocal of, looking at this piece right here at 0, 1, cosine gets smaller than 1, reciprocals get larger than 1, and the closer the number gets to 0, the larger the reciprocal is going to get. So it's going to spiral off to infinity. Same thing goes for down here on the negative side, and then it's going to keep repeating itself. So you notice again, it looks very similar to the cosecant, but it's just shifted around a little bit. So that's the graph of secant, the one in the magenta, or whatever color you want to call it. The period is still 2 pi. The domain is basically anything except for those odd pi's over 2. The range is the same as the range of cosecant. We have all the negative numbers up to and including -1, as well as all the numbers starting at 1 and going up. Asymptotes are the opposites of the domain. Whoops, I didn't want not equal to there. Come on. And the x-intercepts, there are none. And that is a wrap on all of the trig functions. So thank you for watching, and just remember that as far as the graphs of cotangent, secant, and cosecant go, those are more or less just for exposure right now. You're not really going to be doing a whole lot with them, but just so you know what they look like. So thanks again for watching.